Hi, welcome back to AP Physics 1, Unit 1, Kinematics. So in this video, we're going to look at reference frames and relative motion. So this is important because this is what allows us to, a lot of things will say in reference to a person standing outside. So a frame is think about like a picture frame, right? So you see what's inside the frame. And then what happens is if that frame moves, the motion changes, right? So the choice of the reference frame will determine the direction and magnitude of quantities measured by an observer in that reference frame. So if you look in this top picture with the person on a, like let's say a skateboard, to them inside, the ball will travel up and down, right? Because the ball is in their reference frame. And so it's just going to look like natural motion. It's going to go up and down. Now, for the second picture there where the person, same thing, we're going to throw the ball up in the air, but now we're going to look at it in terms of someone from outside that skateboard. So the girl is standing outside watching all this happen. And what you'll see is it traces out a parabolic path because what she is seeing is the ball go up and down, but also move horizontally. So we're going to shift from one-dimensional motion to two-dimensional motion here. And that's what we're going to, and then that's what happens when we combine these two types of motion. So a lot of what we talked about in the first video, scalar and vector, now we're going to look at it in terms of two-dimensional motion, right? Or two-dimensional aspect. So measurements from a given reference frame may be converted to measurements from another reference frame. So that just means that if I'm on, and you can see the boat, if I'm on the shore, the person's going to be paddling straight, but due to the river current, they're going to be pulling them down. And so a lot of times the questions may ask, which direction would the person have to point the boat to go straight across, or where would they end up, right? Something along those lines. Okay. It may be a plane, right? Flying. And then you see, they say there's a, eastern wind as they travel north. Okay. And so it's going to push it towards the east and so forth. Now, the observed velocity of an object results from the combination of the object's velocity and the velocity of the observer's reference frame. And so that means combining the motion of the object will look like essentially addition or subtraction of vectors. And now the acceleration of any object will be the same as measured from initial reference frames. All right, so let's look at an example. So you have a student rolling a ball along the floor. So the ball has a speed of 16 meters per second. What is the speed relative to a second student who is running at 6 meters per second in the same direction that the ball is rolling? All right, so if you draw a picture, you've got the ball rolling this way at 16 meters per second, right, in its own little frame. Then I have a student traveling behind it, traveling at 6 meters per second. And we want to know how fast does that ball look like it's moving to the student, right? And so now we're looking at this, the student's looking at it in terms of their frame. So what's going to happen is it's actually going to take away from the ball speed because the student's already moving 6 meters per second. So the ball is moving at 16 meters per second, right? So basically what we're going to do in this case is subtract out, right, the student's 6 meters per second because the ball is going to have a combination of its speed and the speed of the reference frame of the student. And so the ball, if I'm looking at this from outside, or excuse me, from inside the student, the ball is going to look like it's moving 10 meters per second. So it's going to look like it's moving slower. Okay. So, I mean, this video is very short and quick, right? Because that's what it does is we just look at what happens if we now look at it from outside. So that would be, again, like if I threw the ball up, right? And I'm looking at it from outside, I would see the ball in a parabolic path, right? And this also answers, talks about the question, who's actually moving? So if I'm in a car traveling past students, in my frame of reference, it looks like the students are moving, but from their frame of reference, it looks like I'm moving, right? So, this is when you get in those types. So a lot of these questions tend to be a little bit more conceptual. Okay. I've seen questions where you have someone going up a ladder on a moving train, and what does the path look like, right? To someone who's standing outside, even though the person is going up the ladder, in their frame, they're going straight up it, but to the person who's standing outside of it, they would take like a path at an angle, right? Because they would take their upward motion, stretch it through the motion of the train, and then you would end up with at an angle. All right, so we have one more thing to do in this unit, and that's going to be projectile motion or motion in 2 dimensions. So we'll start looking at some of those like northeast type scenarios. Okay.